Good morning, my dear students. Myself Mahesh B. Koot. Welcome to Tenali Pathshala. So, as you know already, we have started the chapter called Solid State. Already 3 videos I have uploaded in my channel. So, if you have not seen that, this link is given in the description. Please go through that first and then come to this one. This is a 4th lecture on solid state. So, in today's lecture, we are going to discuss regarding packing efficiency. In the previous class, we have discussed regarding close packing. What are the types of close packing? 2-dimensional, 3-dimensional, and wyots. So the further part, that is nothing but packing efficiency. How much amount of space is filled in unit cell, that we have to calculate now in different cases. For in a simple cubic lattice, in a body-centered cubic lattice, and in a face-centered cubic lattice. Okay. So what is packing efficiency, guys? Packing efficiency is the percentage of space, total space, percentage of total space filled by particle in a crystal lattice is called packing efficiency. So packing efficiency is the percentage of total space. Yes, percentage of total space filled by particles. Percentage of total space filled by particles in a crystal lattice. In crystal lattice is called packing efficiency. So remember that. That means how much amount of space is filled in the unit cell. You know what is unit cell and all. In previous class we have discussed it. If you don't know regarding that, please click the link below and you can go through the video first. The previous videos. Then come to this one. You come to know. So in a crystal lattice or in a unit cell, how much amount of particles are filled, that we have to calculate. That is nothing but your packing efficiency. So we have to calculate the percentage here. Remember. So packing efficiency is equal to, there is a formula. Packing efficiency is equal to volume occupied. Yes. Volume occupied divided by volume of the cube. Volume of the cube into 100. See here, packing efficiency is equal to, what is the formula? Volume occupied divided by volume of the cube into 100. So what is this volume occupied? That means how many number of particles are there in our given cube and how much space is occupied by those particles. That is nothing but volume occupied. Yes. Next one, volume of the cube. Volume of the cube means, why we are taking cube? Because, so in whatever the close packing you are discussing, so in all the case we are getting a cube, right? Is it? So 3-dimensional structure of square is nothing but cube. So that volume of the cube we have to take divided by. So what is the volume of the cube formula, guys? Volume of the cube is equal to A cube. Yes. Volume of cube is equal to, what is the formula? A cube. Yes. What is A? A is the edge length of the any side. All sides are same in case of cube. Therefore, A is the edge length of the cube. Any edge you can say. Right. Then what about volume occupied? We will study one by one. Okay. In different case, this is different. So in sphere, what is the volume of the sphere means? 4 by 3 pi r cube. That is the formula for volume of the sphere. What is volume of the cube? Volume of the cube is A cube. Like that. What is A here? A is edge length of the cube. Okay. So we'll discuss one by one. Simple cube first we have to discuss. Then body-centered cubic lattice, face-centered cubic lattice. So out of 3, one is compulsorily you are going to get in our final examination. One is compulsorily asked in our examination for 3 marks. Fixed question. Okay, carefully see here. Starting from simple cubic lattice, one by one. Packing efficiency in case of simple cubic close packing. What is simple cubic close packing, guys? Simple cubic close packing means, see here, only we have studied in the earlier class, the atoms are only present at the corners, not at the body, not at the face. Yes. See, this is a simple cubic close packing. So only atoms are present at the corners. This is a corner. 8 corners are there. You have already studied in the previous class. Okay. Atoms or ions or molecules only present at the corners, 4 below 4. So that is called a simple cubic closed packing. In this case, what is the packing efficiency we have to calculate? What is packing efficiency? Packing efficiency is the percentage of total space filled by the particle in crystal lattice. So how much amount of particles are filled in this unit cell, that we have to calculate. Right. Remember, in simple cubic lattice, two spheres or two atoms are in contact to each other. See here. So if you take this edge, this, let us say this is an A, this is an B. So two spheres are in contact with each other. Okay. This is A to B is one edge of the cube. Here two spheres are contact with each other. What is sphere here? Sphere is nothing but an atom. One atom is in one edge. Two atoms are contact with each other. So what is the radius of this sphere? R. Radius of this sphere is R. So totally one edge is equal to 2R you are getting in this case. Simple cubic closed packing. One edge, two atoms are there. Atoms are considered as a sphere in this case. So when you consider atom as a sphere, so what is the radius of this sphere then? R. So here one R, here one R. So totally AB is equal to how much, guys? AB is equal to how much? 2R. Equation number 1 UT. AB is what? Edge of the cube. Remember, we have just earlier discussed edge length of the cube is denoted by small a. So we take that edge length. Edge length of the cube, how much? Edge length will be A. Yes, AB is edge. So what is that AB? Nothing but A we are getting. Edge length is equal to AB is equal to A. This is number 2. From 1 and 2, carefully see here. Here also AB you are getting. Here also AB you are getting. So AB means what? We can equate RHS side. What is that? 2R is equal to A. Yes, I will write here. From 1 and 2, yes. From 1 and 2, what you are getting? 2R is equal to A we are getting. Just remember this. In further case, we are going to use this one. Now, you know what is the packing efficiency formula, guys? Yes. Packing efficiency is equal to what is the formula? Volume occupied divided by volume of the cube. Yes. What is volume occupied here? Volume occupied in case of simple cubic lattice. In earlier class we have discussed, in a simple cubic lattice, how many atoms are there per unit cell? Only one atom is there per unit cell in simple cubic closed packing. That we have discussed earlier in earlier classes, right? So why 1 comes? See here, 8 corners are there. Corner share is 1 by 8 part. 8 into 1 by 8 means 8 get cancelled, 1 remain. Therefore, for a simple cubic lattice, number of atoms per unit cell is 1. So volume occupied will be 1 into volume of the sphere. Why sphere? Because atoms are considered as a sphere in this case. So volume occupied is equal to 1 into volume of the sphere divided by what is volume of the cube, guys? A cube, as we have already discussed that one. So 1 into 4 by 3 pi r cube into divided by A cube we have to take. I hope you are getting the points here. What is that? 1. Why 1? Because for a simple cubic lattice, only one atom per unit cell are there. 1 into what is the volume of the occupied? Volume occupied is nothing but due to the sphere. So what is the volume of the sphere? 4 by 3 pi r cube. That is a formula. 4 by 3 pi r cube. Whole divided by what is the formula? Volume of the cube is there. You know, so in earlier we have discussed volume of the cube is nothing but A cube. So right here A cube. Next 1 into 4 by 3 pi r cube means 4 by 3 pi r cube. Whole divided by A cube is there. What is A here? See here, guys. A is 2R. A cube means 2R whole cube we have to write. So what is that? 2R whole cube. Nothing but 4 by 3 pi r cube divided by 2 cube means 8 we are getting. 2 2s are 4, 4 2s are 8. R cube means R cube. This R cube get cancelled. So this 4 1s are 4 2s are get cancelled. So what we are left with? Pi by 6 we are left with. Into 100 is there, sorry, into 100 is also there because we have to calculate the packing efficiency. So I will write here into 100 also, into 100. So finally we are getting, what is the value is here? Pi by 6 into, see here, pi is there, 3 comes denominator, 3 into 2, 6, into 100 is there, I am writing 100. So when you put pi value, you know what is the pi value? 3.142. Pi value is 3.142. When you put 3.142 into 100 divided by 6, your answer is 52.4%. What is your answer, guys? 52.4% you are going to get. So just go on calculating that. In place of pi, we have to put 3.142. Yes. Why 3.142? That is a fixed value for pi. You can write 22 by 7 also. That is also fine. So in a simple cubic close packing, what is the packing efficiency, guys? 52.4% is the packing efficiency in case of simple cubic lattice. So what is packing efficiency? Total space filled, percentage of total space filled by the atoms or particles in crystal lattice. So in simple cubic close packing, 52.4% of space is filled. Packing efficiency means this much amount of space is filled. So remaining, whatever 100 minus 52.4, whatever you are left with, no, that much of space is vacant, empty in this case of simple cubic close packing. So what is vacant space then? Vacant space is equal to 100 minus 52.4. Why? 100 is total amount of space. 52.4 is filled space. So total minus filled means empty space you are getting. That is what? Vacant space. I hope you got the point here. This is packing efficiency in case of cubic close packing or simple cubic close packing. Yes. See here what we did. Just I will recall here. First we have taken some simple cubic close packing structure. We know in simple cube, in one edge there are two atoms in contact with each other. And whenever we wanted to calculate packing efficiency, consider atoms as a sphere. So two spheres are in contact with each other. One sphere radius is r, another sphere radius is r. So totally one edge length will be 2r. Yes, edge length AB is equal to 2r I have taken. Then edge length of any cube, in earlier class we discussed it, edge length of any cube is small a. That is what denoted by edge length is equal to AB is equal to a. This is a, this is a, this is a. In every edge length, whatever you are getting, that is small a. A we are getting. From 1 and 2, carefully see here. Here also AB is there. Here also AB is there. Therefore, 2R is equal to A I will write from 1 and 2. Now keep this as it is. Now you put the formula of packing efficiency. What is the formula of packing efficiency, guys? Packing efficiency is equal to volume occupied divided by volume of the cube into 100. Why into 100? Because percentage is there. So volume occupied means how much amount of volume in simple cube is occupied by particles, filled by particles. See, in previous class we have discussed it. So number of atoms per simple cubic unit cell or unit cell is 1. For a simple cubic, it is 1. So therefore 1 into, so atoms is considered, one atom we are getting. Atoms are considered as a sphere. So what is volume of the sphere then? 4 by 3 pi r cube. Therefore 1 into 4 by 3 pi r cube. R is radius. Yes. So this is the formula for volume of the sphere. Divided by volume of the cube is there. So volume of the cube is nothing but a cube. Why you are taking a cube? Because a is the edge length. So a cube we are taking. So therefore 4 by 3 pi r cube. A cube in place of a cube. See here 2r is equal to a we are getting. In place of a, can you replace this 2r? Say in place of a put 2r. Cube is there, cube. 2 cube means 8 we are getting. R cube means r cube we are getting. R cube get cancelled. 4 ones are 4 twos are get cancelled. 3 twos are, because 3 is denominator, comes here in the denominator. 3 twos are 6. Pi by 6 into 100 we are getting. Pi by 6 into 100 is nothing but, in place of pi, you put the value of pi as a 3.142, or you can put the value as a 22 by 7 and calculate by using calculator. You are getting answer as 52.4%. So therefore, in a simple quick close packing, so packing efficiency is equal to 52.4%. And what about the vacant space? Vacant space is equal to, empty space is equal to 100 minus 52.4. Whatever you are getting, that answer is vacant space or empty space. I hope you got the point here. This is in case of simple cubic closed packing. Now in second one we will study FCC, face-centered cubic. That we have to study. Out of 3, one is definitely going to get in your examination for 3 marks. Let us say second one, face-centered cubic closed packing. Look at the name, face-centered. As we have studied in the previous class, face-centered means along with the corners, there are some atoms present at the face. For a cube, 6 faces are there. Front, back, top, bottom, left, right. Total 6 faces are there. So on all the 6 faces, some atom is present. So 1 atom is present, each atom. For each face, 1 atom. Totally 6 atoms are the face and 8 atoms are the corner. What is the corner part? 1 by 8. 8 get cancelled, 1 we are getting. What is the facial part? 1 by 2. 2 into 6 means 6 into 1 by 2. We are getting 2 ones are 2 3s are 3. Total 4 atoms for face-centered cubic lattice. We have discussed it in the previous classes. So if you have not seen, you can click the description box. There I have given the link for previous classes. Yes. So for face-centered cubic closed packing, what is the number of atoms per unit cell? 4 atoms are present per unit cell. Remember that. So what is the diagram is looking like this? See here. See, face means, and any face, I will take this face, some atoms are present. Along with the corners, some atoms are present at the face. So I have taken as a right face, so that you can easily understand. You can take this face, above, below, whatever you can take. I will take this right side face. Okay, I will just join this one. Like this. So, A, B, C. We will write A, B, C. Just name it. Now, here 1 atom is there means here 1 sphere is there. No doubt about that. Yes. And here 1 atom is there means here also 1 sphere is there. Like this. Right. Here 1 atom is there means here also 1 sphere is there. Like this. Yes. So, 1 sphere we are getting 1 R. Here this R, because we are getting the, yes, 2 R's here, R, R. Here only 1 R. So totally AC contains 1 R, 2 R, 3 R, 4 R's. What is AC guys here? 4 R. In earlier case, AB is equal to only are getting 2 R because only 2 atoms are in edge. Here 1, 2, 3 atoms are in edge. So 3 atoms are in one line. Therefore 4 R you are getting. What is AC is equal to guys? AC is equal to 4R. Let us say this as equation number 1. So what is BC? BC is edge length. One edge length is equal to small a. What is AB? AB is another edge. That edge length is equal to again A. AB is equal to A. See here. AB is equal to A. BC is also is equal to A. Then what about AC? See, let us assume ABC is, see here, ABC. Is it a right angle triangle? Yes. Is right angle triangle. Right angle triangle. Okay. According to Pythagorean theorem. Yes. According to Pythagorean theorem, the square of the hypotenuse side is equal to sum of squares of other sides. Hypotenuse side here is AC. See here. Let us take this as a right angle triangle. A, B, C. I have just taken the diagram like this. So here 90-degree angle we are making now. So therefore this triangle is right angle triangle. This AC is called hypotenuse side. Which side? Hypotenuse. This is adjacent and this is, see, this is opposite side. When right angle triangle is there, according to Pythagorean theorem, hypotenuse, square of the hypotenuse side is equal to squares of other sides. That means AC square is equal to AB square plus BC square. Yes. AC square is equal to AB square plus BC square. Therefore, what is AB? AB is nothing but A. I have written here. And BC is nothing but A. Therefore, I will write here A square plus A square. Nothing but 2A square. This is AC square. We want AC. Take square to this side. What it becomes? AC is equal to, when square comes this side, root 2 comes here. Square root get cancelled. A remains. So what we are left with? AC is equal to root 2A. This is equation number 2. Yes. From 1 and 2, carefully see here, AC is equal to 4R we are getting. Here AC is equal to root 2A we are getting. In both the left side, AC we are getting. And in right side, if left sides are same, we can write right side also equal. Therefore, what you are getting then? Root 2A is equal to 4R. So in all the case, what we have to find out first? We have to find out A. So keep A as it is. You take root 2 this side. What it becomes? A into 4R. Here root 2 is in multiplication sign. When it comes this, it becomes divide. Root 2. Yes. So this is R. It is not L. This is R. And you can write 4 into, how we can write a 4? We can write simplification, or else directly we can substitute and calculate. That is also fine. We can take a direct substitution. This is A value. Remember this. Now comes the further calculation part. That is nothing but packing efficiency formula you have to take. Put that value. So up to this you understood now. See here guys what I did. So in case of face centered, one atom is present at the face. See here this atom. 3 atoms are there. Therefore here one sphere, here one sphere, here one sphere. Total we are getting here 3 sphere. In previous case only 2 sphere. Therefore 2 R. See here 1 R. Even this one R, this one R, this one R. Total 4 R we getting. Therefore AC is equal to, I have written 4 R. Yes. And ABC. So I have written here ABC is right angle triangle. So ABC is right angle triangle according to Pythagorean theorem. Which theorem? According to Pythagorean theorem, square of the hypotenuse side is equal to sum of square of the hypotenuse side is equal to sum of squares of other side. That means AC square is equal to BC square plus AB square. That I have written. AC square is equal to AB square plus BC square. AB and BC are the edges. Therefore, the value is A. AB square means A square. BC square means A square. Totally 2A square. So, AC square is equal to 2A square we are getting. We want AC. Take square to this side. When square comes opposite side, it becomes square root. Square root of A. Here square root of A square comes. Square root cancel. Remains with A. Therefore, AC is equal to root 2A. In equation 1, we got AC is equal to 4R. Equation 2, we got AC is equal to root 2A. So, in left sides are equal means we can write right side also equal. 4R is equal to root 2A. That is how I written root 2A is equal to 4R. We want here A. Keep A as it is. Root 2 is here multiplication sign. When it comes this side, it becomes dividend. Therefore, 4R divided by root 2 we are getting. Now, we have the formula. What is packing efficiency, guys? Packing efficiency is equal to volume occupied divided by volume of the cube into 100. So, in that formula, we have to substitute. That's it. See here, you remember this. A is equal to how much we got? I will write here. A is equal to 4R divided by root 2. Okay. This answer I have written here. So, let us take this as equation number 3. Next, if you want to take a screenshot, you can take a screenshot. Yes. See here, next what we have to do? Packing efficiency is equal to volume occupied divided by volume of the cube into 100 we have to take. Yes. What is volume of the cube, guys? Volume of the cube, volume of the cube is A cube. What is volume occupied? In case of face centered, this is face centered, no? In case of face centered, what is the number of atoms per unit cell? I have told you 4 atoms. How? 8 corners are there. What is the corners here? 8 into 1 by 8 plus face centered. How many faces are there? 6 are there. What is the face share? 1 by 2. So how much you are getting? 8 get cancelled. 1 into 1, 1 plus 2 into 2, 3 are 3 into 1, 3. Total 4. So in earlier class we have discussed that number of atoms per face centered cubic unit cell. How much? 4 atoms. Remember this. In previous class we have discussed it. If you are not seen the video, the description I have given the link. Please click that link and go through the video first, then come here. That is the first video itself, I think. See here. Now volume occupied means how many numbers of atoms are there? 4 atoms. Why 4, guys? Because for FCC I have told you how to calculate now. 4 atoms are there. Into volume occupied means volume of the sphere. 1 atom is considered as a sphere, right? So total 4 atoms are there. What is the volume of the sphere? 4 by 3 pi r cube. Formula is same. 4 by 3 pi r cube. Divided by volume of the cube is there. What is volume of the cube, guys? A cube. Yes. Volume of the cube is A cube. So 4 into 4. 16 divided by 3 into, what is that? Pi r cube. Divided by A cube is there. What is A, guys? See here. 4r divided by root 3 is there. You write that. 4r divided by root 3 whole cube we are getting. Because in place of A, we are getting 4r divided by root 2. So A cube means 4r divided by root 2 whole cube we have to take. So what is the answer we are getting? 16 pi r cube divided by 4r cube means what? 4 cube we have to write. 4 4s are 16. 16 4s are, see here, 4 you have to multiply 3 times. 4 4s are 16. 16 4s are. Yes. See here, 16 into 4. 64. 64 into r cube means r cube divided by what? See here, divided by 3 is there. Sorry for that. Root 3 cube is there. So root 3 into root 3 into root 3. 3 times you have to take. Root 3 into root 3, 3 we are getting. 1 3 is left. So what you are getting? 3 root 3. Yes. This 3 get cancelled. 16 ones are, yes, 16 3s are, sorry, 16 4s are, yes, r cube get cancelled. So what we are left with, guys? We are left with, see here, we are left with what? Pi is there, you write a pi. This root 3, denominator of the denominator comes to the numerator. So root 3 divided by what you are getting? 4, only 4 we are left with, into 100. Remember, into 100 is fixed for all, because for a formula we are going to calculate the percentage, therefore into 100. So when you, in place of pi, you put 3.142. 3.142 into root 3 divided by 4 into 100. When you did this, you are going to get 74%. The answer is, in this case, 74% we are getting. So what is the 74% we got, guys? 74% is the packing efficiency in case of face-centered quick close packing. That means 74% of the space is filled by the atoms. So what is left with then? 100 minus 74. What is that? 26% of the space is empty in case of face-centered unit cell. 74% is filled, 26% is empty, vacant space. So how to calculate? I hope you got the points here. Just I will recall here. See, guys. So in a face-centered, one atom is present at each face. Therefore, here 3 spheres are required. What is this 3 sphere indicates? 3 atoms. So this R. Total 4 R we are getting. AC is equal to 4 R we are getting. Yes. According to Pythagorean theorem, ABC, just you take, I have written here, hypotenuse, square of the hypotenuse side is equal to squares of other 2 sides. You get that we are getting the value as how much? Root 2a we are getting. AC is equal to 4R, AC is equal to root 2a. So total equal you make, A is equal to 4R divided by root 2 we are getting. That we have to keep as it is. Now put the formula, packing efficiency is equal to volume of occupied divided by volume of the cube into 100. What is volume occupied? So for a FCC unit cell, how many numbers of particles are there, guys? So for a FCC, total 4 are there. Therefore, I have written here 4. How this 4 comes? I have already told you in the previous classes, first class and second class. Just see those classes. Link is given in the description. See, 4 into what is volume occupied means here volume of the atom is nothing but sphere we are taking. What is the volume of the sphere, guys? 4 by 3 pi r cube we are getting. 4 by 3 pi r cube means, so what we are getting? 4 into 4 by 3 pi r cube divided by volume of the cube. What is volume of the cube formula? A cube. Why A cube? A is the edge length. So then we have already calculated A is equal to 4r divided by root 2. So put here in place of A 4r divided by root 2. Sorry, it is root 2, I think so. I have written root 3. Sorry for that. It is root 2. Yes. Root 2 we are getting. So 16 by 3 pi r cube. This is fixed because 4 4s are 16 divided by 3 is there. Pi r cube is there as it is. Into 100 is there 100. A cube is there. In place of A we have to put 4r divided by root 2. 4r divided by root 2 I have written here. See now. 4 cube means 64 we are getting. 3 times 4 into 4 into 4 we have to take. Then r cube means r cube. Root 2 cube means what we are getting? Root 2 cube means we are getting here 2. Because see here root 2, root 2, root 2. How much you are getting, guys? Root 2, root 2, root 2. Root 2 into root 2, 2. 2 root 2 we are getting. Yes, then this 3 is not going to be cancelled. This 3 as it is 16 by 3. So 4, what are you getting? 64 into 3. 16 ones are 16 fours are. 3 as it is. R cube get cancelled. 2 ones are 2 twos are. So 3 is there at the denominator. 2 is there at the denominator. What you are getting then? Yes, this 2 is already cancelled by this 4. Root 2 comes numerator. 2 into 3. 6 we are getting. Pi into root 2 divided by 6 into 100 we are getting. Yes. Pi into, yes, this root 2 denominator of the denominator comes to the numerator. Root 2. Pi root 2 into 100 divided by 2 into 3 means 6 we are getting. In place of pi, you put the values 3.142. So 3.142 into root 2 divided by 6 into 100. Answer is 74% you are getting. That 74% is nothing but packing efficiency, amount of space filled in case of face-centered cubic close packing. I hope you got the points here. So remaining part, that is nothing but packing efficiency calculation in case of body-centered cubic and density part we are going to discuss in the next video. If you are having any doubts, please comment below. If you are not getting anything means, please go through the video once. But again, you can come to know what is exactly going on. Thanks for watching. Thank you.